Good morning, mathematicians. Good morning to you all. Good morning, mathematicians, except for those of you who never call. Good morning, mathematicians, and maybe some physicists too. Good morning to everyone, if math is what you do. That's it. That's all I got. That's the new intro song I've been working on. Um, what do you guys think? Banger? Good morning, Costa Kachori. I should really wait a minute to sing my beautiful intro songs, because all the regulars who show up for live don't hear them if they're showing up later. How is it math o'clock already? Yeah, crazy. Time flies. Good morning, Zombie Clasher. Glad the intro song is approved of. I mean, I knew it would be. Obviously, it's a perfect song. Mathematically perfect song. Oh, that reminds me of some music thing I could yap on about, but yeah, we'll do some physics. I should probably get my writing pad though. Okay. What should have been the simplest case of all, the free particle. Just a couple of particles hanging out. Just a lone particle striking it out on its own. Floating around in the big world. You want a recommendation for self-study book on special relativity? I don't know. I don't actually have a recommendation. Where did I even learn special relativity? Yeah, I feel like I learned special relativity from like random notes on the internet and like lectures, like Shankar's lectures. Um, yeah, I think that's where I've learned most of the relativity that I know. That's not entirely true. I mean, but yeah, it's all been learned in like there's some other book I have on particle physics, for example. And so there's like an introductory chapter on special relativity in Griffith's book on particle physics. But again, it's just sort of like, oh, it's some random, it's not like a proper book on special relativity. The thing is, special relativity itself, I don't think the basics of it aren't that deep and aren't that long. So probably you could find it in just the intro to a lot of other books. Like probably a lot of books. I'm guessing a lot of books on general relativity. What's my favorite physics topic? Uh, yeah, yeah, but still check Sean Carroll's general relativity book because it might. I wouldn't be surprised if it had an introductory section on special relativity. So, yeah. Oh, I mean Shankar probably has a book on it. I don't know. My favorite physics topic? I don't know. The thing is, I don't. It's hard to say because I don't know a ton of physics that deeply. I took this particle physics course, and we whatever computed. It was mostly setting up integrals connected to Feynman diagrams. That's what we did, and it was cool. I don't know. General relativity seems interesting, and I've learned about again back when I was too young to understand these things. I watched Leonard Susskind's theoretical minimum series, and he sort of gives a kind of derivation of the field equations, and I thought that was really cool. But, I've never like sat down and, worked out solutions. I've never like approximated solutions um, to the field equations. So, have I really done general relativity? I don't know. No particles free until they're all free. Well, they're all there's only one electron. There's only one wave function describing the one electron, right? And so if there's a free electron somewhere, then in some sense they're all free, are they not? Okay, zero potential. Zero potential, just like some of you who aren't studying right now. Boom! Chat roasted. Okay. Okay. Who would I say are the best modern mathematicians? Influence and strength of their frameworks. Well, obviously, Schulze is up there. The problem is I'm blind. I only know so many people. There's a bunch of people in a whole bunch of other fields. Obviously Terry Tao's very influential. Is Clausen? I guess he is pretty influential. He's up there doing the stuff with Schulze, but yeah, of course, Lurie. Yeah, I guess neither of those. Neither of those what? Most famous in influential or impact and influence? Although if you weren't, good morning, Ken. If you weren't sick with various chronic illnesses, you'd probably one of the most influential. Rise above, become one of the most influential ones, anyways. Yeah, Sarah's still alive, so yeah, definitely Sarah would be up there. Yeah, but he dead. Grothendieck dead. Let's see. Norman Wildberger. Yeah. Has he dropped a video lately? I could always use some more reaction content. There's still one video of his I haven't a video of his from recent that I could react to. No, the last one's from 2 months ago. Yeah. Yeah, but 3.2k views. Is it even worth reacting? I don't feel like. I'm like, yeah, he's not even reaching that many people. Grothendieck's biggest mistake, dying. Yeah. Unironically, the math sorcerer is pretty influential. Like millions of at least 1 million subscribers. So could be 3.k plus 1 views with me. I did already watch that one. Anywho, so far it's the same as the infinite well. This time I prefer to write the general solution in exponential form. Okay. Unlike the infinite well, there are no boundary conditions to restrict the possible values of k, though. You really like Normand Wildberger. You learned a lot of history from his history of math lectures. Yeah. Yeah, he used to have good stuff. He used to have good stuff on this channel. Any function that depends on these variables. What? Any function of x and t that depends on these variables? What? What? A function of x and t that depend. What are these variables? What do you mean these variables? A and b? I was thinking the exact same thing, Arad. I was thinking the exact same thing. Yeah, good point, Leo. Rise above. Yeah, Ed Witten, pretty influential. Taking on standard time dependence. Yeah, what do you mean? Any function of x and t that depends on these variables. This is not good writing, I would say. In the special combination for some constant v represents a wave of unchanging shape. Okay. So a function built out of these wave functions? Is that what he's saying? Reading is usually not enough. That's true. Do I have a favorite unsolved problem? Well, my problem is solved. My thesis problem is solved. Yeah. No, the only way to learn this stuff is to do the exercises. My favorite unsolved problem is definitely the Moore graph problem, which I've talked about before. How do you prove that these indices what are corresponding subgroups according to the correspondence theorem? So what's the correspondence theorem? That an isomorphism preserves the lattice of subgroups, or what? Correspondence theorem, normal subgroups. There's a bijective correspondence between subgroups of G prime and the subgroups of G that contain the kernel of a surjective. Wait, I don't think you're saying that correctly. Because what you're saying, G prime and G a priori have nothing to do with each other. What do you mean by G prime? The subgroups of G that contain the kernel of a surjective. Yeah, I think. I think you're missing something here. A lattice theorem states that if n is a normal subgroup of G, then there exists a bijection from the set of all subgroups of G containing n onto subgroups of the quotient. Is that what you mean? Is it Farb? Is that what you mean? He's basically saying you can change variables. Okay. I see. Okay. You must read and do lots of squats, yeah. You have to bang your head on the board very, very hard. That's also true. Yeah. You're reading your third book on functional analysis. Keep forgetting minute details. Even exercises are not fully enough for long-term knowledge. Hmm. Yeah, I don't know. I mean, normally exercises are what help drill in those minute details. Have you looked at all into Yang-Mill's existence? No. It's probably the one I have looked into and understand the least of the Millennium Problems, to be honest. Yeah, I mean, well, depends what details we're talking about forgetting here. You have an opportunity to go to IHES in 2 weeks. There's a lecture on geometric Langlands by Raskin. What would I recommend? Oh, man. I don't know. Study all of math really, really quick. Yeah, I don't know. Oh, would I recommend going? Well, sure, of course. Why not? Why not? If you have an opportunity to go to one of the famous institutions in in all of math, and listen to one of the, you know, currently like top active people in all of math, like why not go? Yeah. It's a good skill to learn which details matter and which do not. Yeah. Also a difficult skill, I would say. You have an opportunity. Oh, yeah, sorry, I just read that. You only encountered Yang-Mills through four-manifold theory? Interesting. I see. Okay, so if phi is surjective, here's what you're saying. So phi surjects from G to G prime. Then there's a bijective correspondence between subgroups of G containing the kernel. Let's say. Subgroups of G containing the kernel. And subgroups of G prime. Okay. Yeah. Yeah, I mean Leo's got a decent hint for you there. Can you turn this surjection into an isomorphism of something? Remember the folklore problem from overflow you apparently solved? Apparently you also found an error. Who's that apparent to? So bets on me, the first year grad student, or the 40 upvotes on Math Overflow, albeit without proof. I want to believe in you, Boris. I want to believe in you. You're really unfamiliar with geometric Langlands. You know the general results and goals, but your interests are different. Yeah, I don't know. I mean, let me also ask this. You say you have an opportunity to go to IHES in 2 weeks and go see this lecture. I mean, how far are you traveling? And are you just going to see this one lecture? Would that be like the only reason that you're going? I mean, in that case, then I wouldn't go. Like, even if it was me, I wouldn't go. I also don't know that much about geometric Langlands. Actually, I heard Raskin give a lecture. I was at a conference last May, and he gave a talk. Um, yeah, but like, I don't know. There's so much context missing here. Like, what do you mean that you have an opportunity? I mean, don't you technically have an opportunity to go anywhere all the time? So, like, uh, yeah, I don't know. Are you saying that there's funding for you to go? And is there more than just Sam Raskin's lecture? And could you also go hang out and do some sightseeing and some networking and stuff? Like, I think there's more details here. You're going for a conference on gravitation, potentially also conformal bootstrap. You're going to France, a different country, so traveling pretty. Okay, so you're already going. You're already going to France. You're already going to be there for a conference, and you're just saying there's that talk, and you're wondering if you should dip in. I mean, probably. I mean, I wouldn't skip out maybe on an important. I wouldn't skip out on an important talk in part of this conference that you're going for, more related to the stuff that you actually do. But yeah, if you can just go, then yeah. Oh, good luck on the interview, Raymond. You can cheeseburger. Leo, what are you, 40 years old? Wait, didn't we establish? No, we established that you're 80 or something. Wait, are you 80? Are you 18? I don't remember. We established this a long time ago. I forget what the canon is on this channel. You just started a course on differential geometry, and you're watching my video on tensors. Hell yeah! I hope my videos on tensors make sense. I never finished the series. Oopsies. Bad boy me. One of these days. Been saying that for years, but you know, one of these days. Yeah, you would do that, wouldn't you, Leo? For the talk, you just got to move your flight back. Essentially, it's whether or not worth shifting your arrangement for Raskin. I mean, yeah. I don't know. The thing is, I would say actually maybe not. Maybe not. I mean, if it costs you nothing to move your flight and you're really interested, then do it. Yeah. But yeah, to be honest, yeah, if it's just so far out of your wheelhouse, like I don't know, I don't think it's so worth it. You know, you could probably just go find a bunch of other geometric Langlands overviews. Particles, yeah. I mean, we've gotten distracted. We're not. We should get back to the quantum. I don't know if I'll put this. This maybe isn't. I might have to change the title of this video afterwards. Not officially quantum. So Leo, you're not doing your axe growth and deek video. I mean, fair, I guess. Yeah, I do think there's some other videos where I've considered doing, and then I'm just like, well, Borchard's is a better one than whatever I would have made, so. Whatever. Okay. Since every point on the waveform moves with the same velocity, you watch Borchards one and was literally like, this one is too good. Yeah. Shape doesn't change as it propagates. Thus, the first term in this equation represents a wave traveling to the right. Wait, 2.94? And the other one represents going to the left. By the way, they only differ by a sign in front of K. So we may as well write that. What? Okay. Okay, sure. Evidently, stationary states of a free particle are propagating waves. Their wavelength is that, according to the Broglie. They carry momentum. Thoughts on string theory? It's definitely a theory. It is definitely a theory. I don't know. I'm not a string theorist. I'm not a physicist who doesn't do string theory, so I know about as much as my opinion matters about as much as anyone else who's read a bunch of pop science articles on the topic. A particle giveaway? Yeah. All this is, it's my appreciation for all De Broglie, that's how I pronounce it. De Broglie? Really? Not De Broglie or okay. Well, actually, what is how to pronounce? Ugh. Broglie, De Broglie, or De Broglie.
Bonjour, this is Julian the Frenchman who makes French pronunciation videos here on YouTube, and we are looking at how to pronounce the name of this French physicist and aristocrat who made groundbreaking contributions to quantum theory. How do you say his name? Louis, which is of course how we say this in French, silent S. Louis de Broglie. Louis de Broglie. I know it is an unusual pronunciation. It's got anything or hardly anything to do with how it is spelt, but that's how it is said in France. Louis de Broglie. Louis de Broglie. French.
Louis de Broglie. Louis de Broglie. Hardly anything to do with how it's said or spelled, but Louis de Broglie. You were absolutely correct, Will. You were absolutely correct. Nerdy Quagsire, nobody over the age of 16 knows who Clavy is. I'm just messing. I'm just mogging, more like. Bro, this guy cannot pronounce stuff correctly. The YouTuber? I mean, okay. Well, Boris, why don't you make some how-to pronunciation videos for us? What do I think about condensed mathematics? I don't think about condensed mathematics. Yeah, I don't know. I've never studied it very deeply, I have a very superficial understanding of what it's all about. So, I don't know. But obviously lots of people think it's fancy and cool, so probably it is. He messes up a lot of stuff? Okay. See his pronunciation of Goethe? It's horrible. Oh. I'll trust you on that one. Am I saying Goethe correctly? Yeah. Here comes that boy. Leo, you are 80. You are 80. Like me, you are 80 years old. I'm a young man, Nerdy Quagsire. I'm young and old at the same time. Okay, fine. We'll go see his pronunciation of Goethe. Julien McQuill, Goethe. Goethe. Maybe I'm saying it wrong. I don't know the right way to say it, so... let's see.
We are looking at how to pronounce the name of German writer and statesman. In German, his name would be pronounced something along the lines of Goethe. Goethe.
Goethe.
However, in English, it is usually said as Goethe, Goethe, Goethe. Or in German.
Is that wrong? I don't know. Is this totally wrong? How do I know that this is totally wrong? I mean, the only way for me to check this is to, like, I guess I could ask my German friends. See the comments? Okay. Yeah, but maybe they're all losers who don't know shit. Well, here we go. All his pronunciations are still horribly wrong. Nice. I mean, damn. 2 million subscribers? Should I make an alt channel where I purposely pronounce things horribly wrong and see if I can get to 2 million subs? The interesting thing is the English pronunciation is 1,000 times closer to the German pronunciation. Incredible. Incredible. Yeah. Incredible. I'm also such a person who doesn't know anything. Okay, that's it. That's it. That's it. Time to chat mog you. How about that? You're getting time mogged. You're getting time mogged now. I love my powers. I love my powers. And I love abusing them as well. Yeah, it is. Well, I don't know. Okay. Although they're certainly totally wrong pronunciation. Okay, sure. I was about to make some totally stupid pronunciations, but okay. There are channels for how to pronounce that do intentionally mispronounce stuff, and to be honest, you feel like you would do that. Yeah. Togged, nice. Yeah, that's a good one. Okay, how long have we been streaming for? 33 minutes? God, time goes on forever. I guess this is a quantum video after all. We're slowly coming back. Coming from knowing Chinese and you go province to province and people pronounce the same shit totally different all the time. Yeah. I mean, that's true, like, in a lot of countries, though. I mean, maybe it's more pronounced in China, but I'm thinking about all the crazy accents that exist within Canada or the United States, if you think about it, like Minnesotan accent versus Texan accent versus like California surfer bro. 6'7", my god, nerdy Quagsire, my god. Years ago, you were Chinese. Wow. How the change times. Okay, the speed of these waves, the quantum speed. The quantum speed of these waves. You're almost Chinese, nerdy Clarks? Okay. Uh, okay. On the other hand, the classical speed. Oh, speed. That's a classic. Classic film. Classic trilogy of films? I think there's 3 speed movies. On the other hand, the classic speed of a free particle of energy E is given by this. Yeah. And so, 2 quantum. That's the sequel to quantum mechanics. 2 quantum, 2 furious. Too fast, too quantum. Oh, it's so good because it's velocity as well. Yeah. Too fast, too quantum. Yeah, you won't catch these waves standing. You won't catch these waves standing around. Apparently, the quantum mechanical wave function. Why is he saying apparently? I thought this was a textbook. He's supposed to be telling me things that are true about the world. Apparently, the quantum mechanical wave function travels half the speed the particle is supposed to represent. Oh, yeah, what the fuck? What the fuck? We'll return to this paradox in a moment. No, tell me now, goddammit. There's an even more serious problem we need to confront first. Oh, this wave function is not normalizable. Okay, so this is where the saying "no free lunch" comes from, because we're not allowed to have free particles, I guess, because we can't normalize it. So separable solutions are not physically realizable states. Oh, okay. I guess we're forced into non-separable solutions. You just can't separate these things. You can't take them apart. I've been thinking about making. I don't know what you guys think. I've been thinking about making a series of videos where I just copy the style of other math tubers. Some would say mock. Um, some would say mock. Um, I don't know what you guys think, but you could call it a cover. I was thinking I could do a math sorcerer type video, a city math tutoring type video. Um, those were the main ones, I said, because those are like personalities and speaking styles I could copy. But I don't know. Am I being too mean if I do that? But then my friend was saying, because I was talking about with my uh, with my interview with G. He was open to the idea of me making like an homage type video. Yeah, like a parody type video. So I don't know. I don't know. I don't know. Yeah, and so sheafification of G, I think so the idea was, if I do it with someone who obviously I get along with first, then maybe it's not just such a mean spirited thing. So I don't know. Things to think about. Things to think about. Probably not till after my defense. I won't think about these things. But yet in American culture at the moment, we are very obsessed with the right pronunciation / almost the right anglicization. Yeah. Yeah. You're at a very Chinese moment in your life. Interesting. Interesting, Boris. Classical Mog's quantum. Yeah, it's literally twice as powerful. It's literally twice as powerful as quantum, as we just saw. So, how to reach the career profiles page of MAA, where you can click on people's profiles and see their history. The link and Google are not working. I don't know. I don't know. What is bro's problem with apparently? Apparently, bro doesn't like saying apparently. Yeah, it's apparent. But I'm not apparent. 1/8 of a scream. Well, who knows? Who could possibly predict what ratio you'll be at tomorrow? Soon we won't even hear you at all. What fundamentally defines a particle? An irreducible representation of SU. I guess it depends on the group. Whatever the whatever group is for the standard model. Why don't I study anything that will help me get a job? Because I'm allergic to making good decisions with my time. Thanks. Thanks for asking. You're going to need a better sentence to get the smaller ratios next streams. I guess so. Off and on again all the time. Is my p-adic hat legit? You mean this one? Is the order link still not working below? I need to look into fixing it. I've just been too lazy to fix it because it didn't seem like that many people were ordering it. But maybe that's just because I don't know. I forgot what I was saying. A lot of brown paper. What to make a parody number file video? Yeah, I could also make the videos over the top, right? Like, I was thinking, like, do I actually explain math in the videos, or do I just say like silly, stupid things? Things to think about. I had it. Who had an interview with Google? K theory parody. Ooh, yeah, I could parody my parodies afterwards. We could get nice and meta with it. A particle is an excitation in a particle field. Amazing, Locke. I love it. I really do love it. That's why you're hoping to get with the professor. To get with the professor? Okay. I don't know if you can say that on stream. That studies representation theory for your PhD program. Hell yeah, you should. Hell yeah, you should. Hell yeah, you should get with your representation theory, prof. Thoughts on mathematicians who sell their souls in order to become quants? Oh, you mean people who actually like can think about the real world and make decisions to support themselves instead of becoming homeless belly button gazers like myself? I think they made good choices with their lives. I think they made good choices with their lives. That's what I think. He studies physics applications of the representation. That sounds based. That sounds pretty based. Yeah. Yeah, money is good actually. I know what you mean. I know what you mean, Will. I know what you mean. I'm just messing around, man. Interview G. Interview with G. It sounded ominous. I think you spelled it right, but it's G plus plus. That's how you should. Oh, G. No. Oh, that's what you meant. You thought I meant Google. No, 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 no. I interviewed the YouTuber Sheafification of G. Yeah. You wouldn't get with your representation there, yeah. Money is scary and the real world is scarier. I agree with you that the real world's scary. I agree with you that the real world's scary, but that's what I'm saying. You know, us little pure I can say this because I'm a pure mathematician. We're just little scaredy cats running away from the real world because it's too scary for us. When it's just like, wow, you know, instead you could just like afford to have a nice life and to take care of the people around you if you just went into finance instead. I don't know. Seems like that would have been the right move. But here we are. Doing quantum physics. Here we are doing quantum physics a couple weeks before our defense in local Langlands. Equivariant derived category something. Guten Morgen, Nadia. Wie geht's? Wie geht's? Wie geht's? Is a real world... Oh, good morning. Oh, I guess, right. It's not good morning for you. Guten Nacht? Guten Abend? Guten Abend? Is a real world what those physics guys are talking about? I think so. I think so. Isn't this the real world? No, the real world is something is like the absolute. This is the real world up here. This one's the real world up here. Except it's not because it's not normalizable. Yeah, better than Lockheed Martin, I guess. Hello, chilled vibes. This is formula for the wave function. I mean, this is a wave function that satisfies a particular. This is a wave function of a free particle. Yo, physics cuber, yo. You've never tried very hard to figure out physics stuff. Well, fair. One could say I'm not trying very hard at the moment either. One could also say that. Okay, hang on a second. A free particle cannot exist in a stationary state. Or to put it another way, there's no such thing as a free particle with a definite energy. God damn. God damn. Can I put all my intelligence into your brain? I may seem intelligent. I may seem intelligent, but you've been reading my paper on the p-adic Lustig hypothesis for GLN? Intriguing. I would be interested to know what you've understood from it. Did you know that I just put up a new version on Archive? I changed a couple things. The new version just went up a day or two ago. But that doesn't mean that separable solutions are of no use to us. No. For they play a mathematical role. Haha, here we are ignoring the real world again. That is entirely independent of their physical interpretation. Yes. I feel comfortable. We can breathe again now that we've ignored the real world. The general solution to the time-dependent Schrodinger equation is still the linear combination of separable solutions, only this time it's an integral. Yes, now we have a continuous spectrum. Now we've got a continuous spectrum. If you just Google Mean Machine Rex, if you just Google p-adic Lustig hypothesis for GLN, you'll find my paper on Archive. Great. This is based and dank that we're seeing both discrete spectrum and continuous spectrum stuff. You've gone no further than Gouveia with p-adics. Actually, I just emailed him the other day. BT Dubs. Hey, maybe I should do an interview with him. Yeah. K-theory theorem when? I don't know. Maybe the Matrix didn't program you to? Wait, program you to do what? That's what happens when I don't read chat fast enough. Quantum computing might give you more incentives to dive deeper into physics. That is fair. That is fair. Did someone say spectrum? I did, but not the kind of spectrum that you were hoping I was saying. Ken from the Bee Movie? Is that Seinfeld's character? Collecting the interview aura, yeah. Do I actually understand this stuff for real? Yeah. Yeah, I would say so. I could understand it better. 49 minutes in, this means bro's quitting in 20 seconds. You're not totally wrong. You're not totally wrong. There's like a train of thought I want to. I'm gonna get down to here and then I'm gonna stop. So, yeah. The quantity here is factored out for convenience. What plays the role of the coefficient is that. Now, this wave function can be normalized for appropriate phi k, but necessarily k carries a range of k's and hence a range of energies and speeds. We call it a wave packet. Not to be confused with an L packet. Ayo. You're on the spectrum, if that helps. Yes, it does. It does. It most certainly helps. Is this easiest way for you to learn reading papers? I know of no other way to. I mean, there's only two things that you can do to learn math, and you must do them both. You have to read math and you have to write math. By the way, e to the IE stuff also shows up in your Galilean cohomology video. I may have to rewatch that again before too long. You're neuroconvergent. Nice. I'm neurocoshi. Whether I'm neuroconvergent. So I'm not neurodivergent. But whether I'm neuroconvergent remains to be seen. But yeah, I can definitely tell you I'm neurocoshi. But we don't know that neurospace is complete. You're on a spectral sequence, so I hope may your pages not collapse. May your pages not come tumbling down. In the generic quantum problem, we are given this. We are asked to find that. For a free particle, the solution takes the form of that. The only question is how to determine the phi k so as to match the initial wave function. This is a classical problem in Fourier analysis, and the answer is provided by Plancherel's theorem. Beautiful. Beautiful. You love to see it. Folks, you love to see it. Plancherel's theorem. Has anybody cooked up a quantum Langlands program yet? You're almost sure this already exists. Yeah, I know that the certain flavors of Langlands have connections to quantum stuff, but yeah. And I mean, undoubtedly, I mean, also the orbit method. The orbit method. I'm not gonna pull the book up, but just go look at this. David Vogan, orbit method, and QM. I mean, yeah, obviously the Plancherel, obviously, you know, Fourier stuff, and Plancherel have roles to play in the Langlands program, but then there's also this, like, I mean, this has come up now, like, several times in the last few streams, this fact that the orbit method in representation theory is somehow some generalization of the passage between classical and quantum systems. Neuro oscillating. Yeah. The harmonic neuro oscillator. Yeah. Yeah, you're not bipolar. You just satisfy the differential equation defining the neuro harmonic oscillator. So, you thought that Laplace transform? What was Laplace transform? Well, I mean they're related. They're similar kind of thing. The orbit method dies, huh? Plancherel. Fourier transform, Fourier inversion. There is, of course, some restriction on the allowable functions. The integrals have to exist, after all. And so what? We put this in L2 intersect L1, I guess. Well, and of course, this itself has to be normalized. So solution to the generic quantum problem for a free particle is this. Uh-huh. Nice. Okay, and we'll look at an example next time. Nadia is 50. Today or soon? Soon. Es meine Geburtstag. Soon. Ah, man, I've forgotten all my German. Ich habe keine Ahnung. 10 years ago, you had the Vine Cone read a comment of mine. I don't know who that is. In a video where you make a joke about the quantum harmonic oscillator annihilation operators. A moment that you hold on to dearly, no doubt. Yesterday, you claimed that left translation in a group defines a group automorphism on the group. It can. Wait, no, I don't think there's a single example where it can. Well, yeah, I know one example where that's true. I know one example that's true. What letter do I use? Does a photon follow this free particle wave function? I would suppose so. I suppose if you imagine a particle, you imagine a photon traveling in free space. You know, um, it's also why we call it a wave packet. But I guess we'll get more into these details later. The wine cone was one of the biggest early YouTubers. Oh, maybe I'm too young. I don't know. Are we not approximately the same age, Nikolai? I'm not that much younger than you. I see. But 5 years? Oh, are you 5 years older than me? Wow. You claim specifically for non-identity elements. I see. I see. Anywho, you need to learn more complicated logic so it can deal with several different kinds of continuous weights at once atop a number of modalities. Well, you should talk to Nikolai. I feel like he might know something about that. But you'll have to do that another day because it's time to go. And so I must say to you all, QED, QED, let me be free as a particle.